Hey, welcome to this little chemistry installment on the mole. So this comes up a lot in chemistry, and what is a mole? And you might hear it talked about when people talk about their chemistry class, but they say mole, and it sort of brings these feelings of doom and whatever. So what is it? It's really actually not a difficult concept to understand. Hopefully I'll be able to show you that in this quick little video. But first of all, we have to kind of understand what it is and what it isn't. And the biggest reason why it's difficult for anybody to understand is just because it really represents something huge. And so people have a hard time grasping just the immensity of it. So what is a mole? Okay, let's just take a look at this. Oh, nope, not that. So that was kind of scary. So what is it? Let's go ahead and get into this. Oh, that's gross. Okay, definitely not that. Here's what a mole is. A mole is simply a number that we use to count very small things. So if you think of atoms of carbon, how big is an atom? Well, obviously it's microscopic. It's more than microscopic. I mean, we can't see atoms with a microscope. We might be able to see the biggest atoms with an electron microscope, so maybe some gold atoms. But in general, we cannot even see atoms with a microscope. So here's the idea. A mole is simply a number. It's a counting number. And the counting number is like this. It's 6.02 times 10 to the 23rd, which is actually 602 sectillion. So if you were to write it out, you have a 602 with 21 more zeros. So I don't even know if I can put a comma there. Let's go ahead and erase that. So let's go ahead and do that. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. So in all we have 623 places here. We'll move that decimal. Now that is a big number. If you had this amount of anything, you would have an enormously huge amount of stuff, unless you're talking about something as small as an atom. So if you look at this right here, a mole of carbon is about 12 grams, which means 1 mole of carbon, which is 602 sectillion, or 6.02 times 10 to the 23rd of carbon, equals 12 grams if you were to weigh it out. 12 grams isn't much. It's about the weight of 12 little paper clips. And so you could weigh it out on a small little tray like this. This is kind of showing the idea. So why do we use this? Well, it's the same reason that we use dozen. A lot of times we don't sell a single egg. You want to sell more than one egg at a time. And so we've decided that we'll sell eggs in groups of 12. So if I tell you that I have 2 dozen, you know by very, very simple math that you're going to have 24 eggs. How'd you know that? Well, you know that each dozen equals 12. Same thing with this. Each mole equals 6.02 times 10 to the 23rd. So if I have 2 moles, well, I have this number times 2, right? And what if I was to tell you that I had 36 eggs, right? If I had 36 eggs, I'm going to say, how many dozen is that? Well, you would say, oh, that's 3 dozen. And how would you know? Because you would say, well, there's 12 eggs in every dozen, so I'm going to divide that. 36 divided by 12 equals 3 dozen, right? Same thing with this. If I told you that I had 5.72 times 10 to the 25th atoms, that's a lot of atoms. How many moles of atoms do I have? Well, I want to know how many sets of 6.02 times 10 to the 23rd do I have. So I'm going to divide that just in the same way that I would have done it with eggs. So while visualizing 12 or a dozen is easy for us, visualizing this is not very easy. And so that's where the confusion comes in, but yet it's really the same concept. We want to have a number for counting atoms that makes atoms workable, like that gives us actually amount of atoms that we can do something with. Here's another example right here. We measure paper in reams, so it's 500 sheets. You don't buy it by the sheet. You'll buy 500 sheets at a time. So how many reams do you want? Well, if I said, I'm going to give you 2 reams of paper, you'd say, oh, great, that's 1,000 sheets. How'd you know? Well, because each ream is 500, so you would say 2 of them must be 1,000. What if I said, okay, I'm going to give you 2,000 pieces of paper? How many reams is that? Well, you'd say, okay, well, every ream is 500, so that's a total of 4 reams, right? So we're able to even do it with bigger numbers like 500 or 2,000 or 3,000. But all of a sudden you start working with 602 sectillion, and it gets a little bit more difficult. But keep in mind that it's no different than this. And if you have to bring your mind back to this whole dozen idea, go ahead and do that. Now here's the other neat thing about it. 1 mole, if you're going to look at the periodic table, 1 mole of anything actually equals the mass that is found on the periodic table. So if you look right here, you have this thing called an atomic weight or atomic mass. Typically it's a decimal, but this is just for illustrative purposes right here. If we look at nitrogen, the mass of nitrogen, which is going to be found here on the bottom, it's the bigger number, is 14. So that means if I was to weigh out exactly 14 grams, hang on 1 second, let me turn that one on. If I was to weigh out exactly 14 grams of nitrogen, I would get exactly 602 sectillion atoms of nitrogen. So this is really handy, because if I told you I have 24 grams of nitrogen, well, how many atoms do I have? Well, it's this times 2. So you could figure out exactly how many atoms of any element you have at any one given time, because all you got to look at is the mass that's on the periodic table. And that amount of grams right here, like iron right here, 56 grams of iron is going to give you 1 mole of iron. All right, so how do we work with this? So let me show you what we do here with mole conversions real quick, and this should be pretty simple, and we'll do this really fast. So let's just say that I had 3 moles of iron, right? So how many iron atoms would I have? Well, I know that every 1 mole equals 6.02 times 10 to the 23rd. So I'm just going to multiply it times 3, and then I'm going to get an answer. So I'm going to go ahead and do that. I got 6.02 times 10 to the 23rd times 3, and I find that I have 1.81 times 10 to the 24th atoms of iron. So I just multiply it. So let's go ahead and get kind of a little pathway here to follow. So if I'm talking about particles, now particles can be a lot of different things. They can be atoms, anything small that we would use a number this big to count with. So we've got atoms, it could be molecules, right? It could be formula units. So we're talking about the smallest things that are around us. We're going to call those particles. So if I was to go from particles, or if I was going to go, here's what I did. I went from moles, right, to particles. I turned my 3 moles into 1.81 times 10 to the 24th atoms. So if I'm going to go like this, from moles to particles, here's what I'm going to do. I'm going to multiply by 6.02 times 10 to the 23rd. So you can draw yourself a little sort of chart like this to help you remember. Okay, if I'm starting with moles, going to particles, I'm going to multiply by 6.02 times 10 to the 23rd. What if I go the other way? What if I said I want to turn those atoms back into moles, right? So I want to know that. Well, to get back from there, you would say, how many times does 6.02 times 10 to the 23rd fit into that, right? Just like the dozen thing. If I give you 24 eggs, how many dozen is that? Well, how many times does 12 fit into that? It's 2, right? So since this is the number for mole, then we would divide. So if I'm going back from moles to particles, then I would say I would divide by 6.02 times 10 to the 23rd. All right? Now, we also can go the other way. What if we have grams or mass, right? So mass is always measured in grams here. We could say mass right down here. And so what about that? What if I said, okay, I've got 112 grams of iron, right? Let's go back to my periodic table over here, and let's check it out. Well, iron is 56 grams in 1 mole. So I look that up, and I say, okay, so now I know what iron is. It's 56 grams in 1 mole. Right? So if I have 112 grams, well, I would say, okay, how many times does 56 fit into that? right? And so if I do that, it's 2 times. So here I have 2 moles of iron, because every 56 grams equals 1 mole, right? So I'm going to divide. So if I'm going from grams to moles, right? If I'm going this way, from grams to moles, what I'm going to do is I'm going to divide by molar mass. And so that's what we call this mass then on the periodic table. We call it molar mass. So all you got to do to find molar mass is look it up. Now what if I'm going to go from, oh, you know, I drew this arrow wrong over here, and that makes me feel bad for you. So change it. Hopefully you didn't use pen. Yeah, because if I was going from particles to mold, I'll divide. I just realized when I look over at this one and I saw that my arrows on the other side were going the same direction. That's really not helpful. So sorry about you who noticed that and that's bothering you so far. Just ignore it. Anyways, if I'm going from moles to grams, right? What if I said I have 3 moles of sodium? And I want to know how many grams that is. How much does that weigh? 3 moles of sodium. Well, here's what I'm going to do. I'm going to look up sodium. I'm going to say, okay, here's sodium. My molar mass of sodium right here I can see is 23 grams. Okay? So if every 1 mole of sodium is 23 grams, I'm going to multiply by 23. Okay? 3 times 23 is 69. So I've got 69 grams of sodium. Right? So there we go. So then that was pretty easy. So then if I'm going from moles to grams, I'm going to multiply by molar mass, right? There we are. So this is all correct now. You can see that there's arrows going either way. So now you could just take and you could draw yourself out a little chart like this, and you could use it. And anytime you're doing any mole conversions, going from grams to moles or from moles to grams, you could use this. Now, one other thing that comes up is that what if we were doing a particle? Like, what if I said I have 30 grams of CO2, and I want to know how many moles that is, right? So I have 30 grams of CO2. Well, so let's look first of all, where am I starting? I'm starting with grams and I'm going to moles, right? So I'm going to divide by the molar mass. Well, the molar mass of CO2, what is that? Well, it's pretty simple. If you look at this, I have 1 carbon and 2 oxygens. So to figure out the molar mass here, all I got to do is add those all up. So I'd say, okay, I have 1 carbon, so that's 12, and I have 2 oxygens, so that's 16 times 2, so that's going to be 32 plus 12, so that's going to give me 44. So I'd say, okay, my molar mass is 44 grams in 1 mole, right? So I divide that out, 30 divided by 44, so 30 divided by 44, and I won't have a complete mole, but I'm going to have 0.68 moles of CO2, okay? So not a full mole, because in order to get a full mole, I need 44 grams per mole. But you can do that with any compound to use it in the same way. As I could say, okay, if I've got 0.68 moles, then how many particles of CO2 would I have? Well, then I'm just going to multiply then. If I'm going from moles, once I know moles, I can go from moles to particles. And I could say, I'm going to multiply that by 6.02 times 10 to the 23rd, and I will get the exact how many molecules of CO2 I have. So you can work your way down this in any direction and use this to easily convert moles to mass to particles, and back and forth. You can do it with single atoms, you can do it with full molecules, you could do it with formula units, or you could even do it with moles if you wanted to, but hopefully you don't have that many moles. All right, we will go in the next one and talk about solving empirical formulas.